Hello, welcome to another Verasys video. My name is Rob Snard, and today I'm going to talk about the ZEC410 controller. The ZEC410 controller is used for VAV systems. It's our VAV box controller, as well as it's used for changeover bypass systems. So one of the things that most people don't, or a nice feature that about the ZEC410s is the fact that we can use them for changeover bypass system. So I'm going to log into my Verasys system, as I'm going to be going over how to set up this VAV controller. In my case, it's going to be a changeover bypass system, and how to get it, set up. So my Verasys system, as I get logged in, has two VAV box controllers on it. So I've already set the name of the box, so I can do that through Edit Device Details. Just got to make sure that I don't go over 30 characters. So that's on both the name and the description. So I've already set that. The address is already set. It's a switch on the device, and I've got it wired to the zone bus of the zone coordinator. These controllers have to set on the zone bus of the zone coordinator. They do not go on the system bus. So please refer to the Verasys MSTP guide for that wiring if you need to understand where things wire. So I'm going to go ahead and I'm going to go ahead and dive into this controller and talk a little bit about the setup. So as I jump into it, you can see the different menu settings over here on the left and the different parameters over here on the right. If you want to know the different parameters or anything about these parameters, so let's say you want to know what zone vote means. So you can go to or refer to the Verasys User's Guide. The Verasys User's Guide is pretty instrumental because it's going to go over what I'm going to go over, which is the setup of the VAV box. As you scroll down for system setup, we have setup procedures for VAV systems. We have setup procedures for changeover bypass systems, all the way down to the specific controller. So if you've got a 410 controller, here's how you set up the ZEC410. Same thing on the changeover bypass is how you set up the controller for changeover bypass. The setup procedure is pretty much the exact same thing for whether it's changeover bypass or VAV. Just a couple little parameters that'll be different on a changeover bypass system than a VAV system, but we'll go over that here in a minute. Wanted to refer to you to objects and parameters. So objects and parameters is for every Verasys controller, I have what the menu is and the object and parameter is. So in that case, it was a ZEC410 controller, which is a unit controller. But I can skim through this if you have it electronically on your laptop. You can skim through it you can see a bypass controller. Okay, there I've got a ZEC410. And now I can see what zone vote means. So it gives me a description of what that means. So anyway, if you're trying to figure out a parameter or something like that on any Verasys controller, refer to that user's guide. So I'm back here on the home page, and the home page is just an overview basically of the controller. So from here you can determine whether or not you have some issues. So it looks like right now I have a fan and a heating stage, and my biggest issue I see is the fact that my supply flow is not matching my flow set point, but my damper's 100%. Remember, I'm using a demo panel, so I don't really have air to this, but you should see on your controller, if it's controlling properly, a damper position not at 0 or not at 100, but somewhere in between, trying to modulate this flow. And that should be pretty much all the time. If you've got 100% and you know you have air, you know you've got a starved box or you got damper shut somewhere down the line, you got a problem. So anyway, it's a quick way to diagnose what could be going on. It could also tell you whether or not you've got your system set up right, because you're going to see fan commands and heating stages. I happen to be using the -1 model of the controller. The -1 model does staged heat. The -2 is incremental, and the -3 is proportional. So depending upon the model, you get slightly different screens, but they set up about the same. Each controller will have will come with a quick start guide. So the quick start guide gives you kind of a quick overview of what I'm about to show you. So first you start out with equipment setup, then you go to the commissioning of the box, and then you can go to any kind of control setup that you may have at some point in time. So I'm going to start out with the equipment setup. So I hop over to the equipment setup, and here's where I can set how many stages of box, what type of heat, the fan, do a few other things. So I'll go through each one of these parameters. The actuator stroke time is how many seconds does it take to go from closed to open on the box. The actuator that we have, it's a 60-second actuator, and generally I don't ever really adjust this. If you needed to, give it a few extra seconds. I wouldn't adjust it any more than 5 seconds one way or another. But that's what the parameter you use to set that actuator stroke time. It's already kind of set for you. Damper polarity. Damper polarity is very important. So what type of box will depend upon, is it clockwise or counterclockwise? So one of the steps in actually setting your connecting your box up to your damper, connect up to the VAV box, one of the steps in the installation instructions, so I'm going to flip over to the installation instructions, is to adjust or check this manual coupler. So when you first connect up your box and you screw it in, before you leave or get off the ladder, you need to check this. If you press in this button and you move this collar, then you're done. Okay, so you've got it where this collar can move. You know, it's tightened down and it can move left and right. Then, because if it can move manually, then it can move programmatically. So at that same time, you should be aware of, are you clockwise or counterclockwise, and figure out what that is. So that information is pretty important to set. So I'm going to switch it to clockwise here in a little bit, just to show you what other things that this does. So I'll jump back to the screen and switch to clockwise. Box heating installed. This is telling you, okay, is it do you have heat installed? So generally you're selecting it based off of heat, but if you had a cooling only box, you'd set this to false. So I don't have heat, don't have this. If you don't have heat, there it's would shut off. And what that's going to do, go back to the home page. Notice I lost my heating stages there. So it kind of sets up how the box looks, you know, even from a view standpoint. So I'm going to say I have a couple of heating stages, and we'll move it to 3 heating stages. And if I go back to my home screen, I should see 3 heating commands, you know, status of them. Supplemental heat. This is where you would set your stage for supplemental heat. The -1 has a single stage supplemental heat. The -2, it's an incremental model, so therefore it's incremental heat. The -3 is a proportional model, and the supplemental heat is still incremental as well. So depending upon the type of box will depend upon the supplemental heat. So you got to be careful there that that you have the right heat or supplemental heat going in to match the box. The last couple of parameters is the fan type. So you can set it from series to parallel to no fan. Parallel is used generally for heating, or the sequences between the three are series fans, always on when you're occupied. Parallel fan is usually on when you have heat, and no fan obviously is just a single duct VAV. Then final parameter is a zone temperature offset. So if you have a zone temperature that's reading a degree or so off, you can adjust that. So if it's a degree high, you would make this a negative. So what it will do, it will take what it's reading and it'll add a -1, which is subtracting 1. If it's a degree low, you would add a degree. So that's how you would offset to get your temperature to read what you're measuring. Most cases, you just leave that at 0. Temp sensors are pretty accurate right out of the box. Okay, so just like the quick start guide referred to, is the next step is going to be commissioning. So when you commission a VAV box, you're setting a lot of parameters. You're setting what your cooling maximum, your flow parameters. You're also setting your area, your pickup gain, and just setting a number of things. So you get all this information off of a schedule, mechanical schedule that might be on the prints, and so you're generally told what you need to put in here. The cooling maximum is when you're in cooling, your temperature will go, because a VAV box is always given cooling, your temperature will go from minimum all the way up to maximum based upon how far you are from set point, based on the PID process. So when you're satisfied, you should be down at your cooling minimum. On heating is a constant flow. So you'll have a heating set point, and generally your heating set point will match your cooling set point. There's another on a staged heat or electric heat box, another set point that you have to set, which is stage reheat minimum flow. I'm going to jump down to that. What that means is, we're going to set this up to 700, is, let's say you are satisfied at heating. You'll be at the 400 CFM. But let's say you needed a call for a heating stage, so you need one of those 3 stages to come on. The flow, once it turns on that heat stage, the flow will ramp up to 700 CFM. What it's trying to do is it's trying to give some additional CFM to make that airflow switch that is on that electric heat. So you have enough airflow going across that electric coil. Otherwise, what happens is, if you don't have enough flow, there will be a flow switch in there that doesn't make, and those won't turn on. So generally, when you have staged reheat, you may need a little extra flow than what you have for minimum. So this gives you the opportunity to set that. The other flows are cooling minimum flow and heating minimum flow. Generally, these are set to 0. You kind of have to be a little bit cognizant that you set those to 0. So if you have a VAV system and your representative zone is a particular box, you want to make sure that your representative zone is set with its set points a little bit higher. Its unoccupied cooling and heating set points are set a little bit higher than other boxes that are set to 0. So that way you have enough flow, or enough boxes calling for night setback to come off, so that you have plenty of airflow. So anyway, always be cognizant when you set that to 0. Warm-up minimum flow is if your VAV unit or your VAV unit would be what has warm-up. Changeover bypass does not use warm-up, but if you have heating stages and you have a reheat sensor on your unit, or you have not reheat sensor, a return air sensor, you would have the ability to, when it schedules and turns on, that heat could come down the duct until it warms up to a particular setting. The return air warms up to a particular setting. In that case, you're going to have the box will use the heat and modulate from minimum to maximum. So this is where you could set your warm-up minimum, and generally you set that to the same as your heating minimum. Down here we'll have your supply airflow and set point. So this is where you can see how well you're controlling the set point. In my case, I don't have flow on my box, so therefore I'm not really controlling, whatever I'm modulating isn't really doing a lot of good because I don't have flow. The other next two parameters are the supply area and the pickup gain. So I'm going to refer to the user's guide again. So let me go all the way up to the top to refer to it. Under the Appendix A, here are the JCI VAV box manufactured characteristics. So with the JCI VAV boxes, I can tell you what's clockwise, counterclockwise, etc., which manufacturers are set which directions. So underneath Table 8 is some quick fill defaults. So done some quick calculations. It's pi r squared for area, and it's set in square feet. So I can give you the square footage of a 10-inch damper per se. It'll be 0.55. So that if you had a 10-inch box, this is what you would input for area. Pickup gains will differ based upon the manufacturers of the box. Each manufacturer will have a different pickup gain. So why is that? Now I'm going to jump over to a PowerPoint real quick and show you. Let it get set up. Let me swap the display. So a pickup gain looks like this. It's a flow cross in your box. So what the flow cross does is it picks up the area. It'll take and it'll have holes for total pressure. So it'll feel the total pressure of the air coming in, and then static pressure. So there's holes on the front side and there's holes on the back side of this probe. And it will calculate the velocity pressure. So the velocity pressure is the total pressure minus the static pressure. And then it's put into a formula to calculate flow. One of the parameters of the formula is the pickup gain. So each one of these types of flow crosses have different characteristics of that pickup gain. Our VAV boxes, you'll notice that this pickup will have tubes that run out of it. You plug the tubes into our controller. Our controller is not polarity sensitive. So if you've got them, one direction, the static on the there isn't a wrong side to it. You can put it on either port. We basically take the absolute value of this, so we're always using a positive value. So when we set this box up, we need to know roughly what that pickup gain is, and then that's where this chart comes into handy. So this would be the pickup gain for that 10-inch box at 2.32. You can kind of see if you don't know your pickup gain, if you guess something right around 2, you may be about right. But anyway, this pickup gain also is adjusted by a balance contractor. It's their means to adjust what the final flow should be. So this chart is here to tell you what our JCI pickup gains are. If you don't have a JCI box, then you'll need to figure out through the manufacturer what the gains are. If you want, you can call our Verasys support hotline, and we can work with you and try to help you figure that out as well. So feel free to call that. So I'm going to jump back to our parameters here, and now you should understand a little more what pickup gain and what supply area are. So the last few parameters, as I'm not going to go over the load shed parameters since that's specific to the load shed feature, which will be another video. The last few parameters are showing you a little bit of the calibration of our sensor, our velocity pressure sensor. So this velocity pressure reading that I have right now, that is the velocity pressure from that port. So I have a little bit of flow. You generally have a little bit of airflow, in a space. So there is a little bit of CFM that this might read. So the next few parameters is auto calibration, or the calibration of that. Notice down here I have a value in my auto calibration offset. When you power up the controller, it will drive the damper closed, or what it thinks is closed. And then it will read the velocity pressure and then subtract it. So that way your net result is 0. So that happens whenever you cycle power on the controller. Now, one of the things that you can look at this offset, and you should have a low number like what I show right here. You have almost like a 0.1. It means that you might have been fully open when you calibrated that. So what would cause it to be fully open? Well, chances are when you had your damper polarity set wrong, it could have offset that, or it could have done an offset. So if you're near 0 and you know that you're full open, you know, what happens is it's that auto calibration. So when I'm going to go ahead and I'm going to switch. I know earlier I had said that I'm going to switch this from counterclockwise to clockwise. So I'm going to switch this to clockwise. And now I'm going to go back to commissioning. And now you're going to notice that the controller itself is now waiting to calibrate. So if you were here where I'm at, you would hear the controller moving right now. So it's closing. And what it's going to do is it's going to fully close. It's going to drive that actuator that full 60 seconds. And then it's going to take it and offset what it's reading here, so that way it zeroes out. So right now I'm reading a 0.01, and my calibration offset is going to end up being, minus 0.001. If you need to, or you think that the calibration is wrong, you can manually set that. But because of the fact that we built it in with the damper switching the polarity, that's 99 out of 100 times is what caused that to go bad in the first place. So, or another thing that could have caused it would be you didn't have your coupling on it, on the damper, and then you finally got your coupling on and you got it hooked up right. So if you did need to auto calibrate manually, this is how you would do it. So that's the commissioning piece of a 410. We can go through control setup. A lot of these parameters you can go into, like I said, the user's guide, and go to the appendix B. So appendix B is the next appendix down, and get those parameters and look through that. So if you want to know what each of these do, but I'm going to touch on one, and that's going to be the demand ventilation enable. Demand ventilation enable means you're going to hook up a CO2 sensor. So you wire a CO2 sensor to your net sensor bus, or SA bus, and it will show up here on the home page somewhere down below the supply air temperature. And so once you do that, you need to turn it on if you want to use it. So turning it on means I'm going to put this to CO2, which will enable it. When I did that, under commissioning, notice I've got some minimum and maximums to set up. So this is where I can set my minimums a little slightly higher than what I have initially. So therefore it's bringing in more CFM on a minimum side, and thus getting rid of some of that CO2. The other thing that it does is it sets up, I believe it's under here, is the settings for the demand ventilation. There it is, under commissioning. So the demand ventilation settings are here as well. And that'll set where do you want at what level do you want to start demand ventilation control. And then it goes from a minimum 700 all the way up to a maximum of add 4 to it, or 400 to it. So if I get up to 1100 ppm, that means I'm going to be fully ventilating at that point in time. So that's step one. That's getting your box set up for demand ventilation. The other item that you have to get is your unit set up for demand ventilation. So you need to go to Details, Service, and Factory and turn on the demand ventilation feature. So if you have an economizer, you must have an economizer for this to work. And then you would set that to on. So what that will do will be the box will then talk to the unit and let it know, hey, I'm in a demand ventilation cycle right now. The unit then will open its damper 5% every half hour. Okay, to speed that process up, you can go to the zone coordinator, and under commissioning, you can put the Title 24 test mode to true. And that will then speed up the process. In other words, it'll go 5% every 2 minutes. So if you have to test it and make sure it's working, that's how you would test it. So, like I said, the rest of these control setup pieces I won't go over. They're all in the Appendix B. And this is how to set up the VAV box when you have the VAV box connected to your zone coordinator. This isn't the only way to set up the VAV box. So I'm going to refer back to my PowerPoint and jump now to another little section. So I have a picture here of a controller on the floor, and I've got it hooked up to a stat. Normally you'd have this wired to the zone bus actuator. I just took a little jumper cable over. But I can take my SA bus, my smart building hub, and connect it up to the box directly, either at the controller, or if this port is free, I could connect it to the stat, which then would talk to the VAV box. I could then take and Wi-Fi into my smart building hub. When I do that, and let's say all the devices have been removed and this is the only one on there, the VAV box will show up. So from that means I can then get into the box and set it up. So you'll notice that if you directly connect to it, it'll look a little different. That's because the zone coordinator is the smart device on the is a smart equipment device. And what that smart equipment device does, it allows us to change the view definitions, organize points, allows for trends and scheduling. Notice there's no trends or scheduling in this menu. It's all just inputs, outputs, parameters. And it's specifically that way because this controller can't hold a view definition. So we made a view definition for it. And it's simply just inputs, outputs, parameters, and we can have a home screen for it that we made. One of the other things is it doesn't have the long names, it shows short names. So the short names are fairly, you can kind of cross-reference them from what you've seen. The one that's a little bit different is damper mode. Damper mode is the damper polarity, and it's normal or reverse. So there's some little nuances to it, but from this, you can adjust all the things at commissioning that we did before and adjust things like fan type and set up the fan. So underneath there too, you can commission it. So you could here physically override heating stages on and then release them. So through this setup, we can set up the box right there locally, and then when it's plugged in, it'll be all set up. One of the things to make sure that you do, like when you set the damper mode object, make sure you change in the default on any of the on all the parameters. So if you say to change a value, change the default value. Some of them you have no choice but to change default, but others you could override or set state, and you don't want to override, you don't want to set state. What that will do, if you cycle power on that controller, you lost all your changes. So change the default value. That's what gets saved. There are about 10 VAV box parameters to change. I did a little quick cross-reference between some of those parameters here. So anyway, that's kind of some of the short names to what you saw on the Verasys side. Again, a lot of those parameters, they come from a schedule that's for the job. Generally, your box supplier could also tell you what the minimum and maximum should be for each box. Remember the quick fill box details, and then also um, a little bit about the pickup gain as well as the counterclockwise, clockwise. I've referred to the user guide, what, 3-4 times now. So this user's guide is a critical piece of information to go over, not just for the VAV box, but for all the other setup for a smart building hub. So I would get to know this piece of literature very well. Anyway, that concludes my the video on the ZEC410 and how to set it up in Verasys. Thank you. Hope you watch some of our other videos.